What's up, guys? Welcome back to another episode of Stonks Maxxing. So, I'm in a little quiet area, so I'll try to whisper here. But, and in this episode, I kind of want to go over some things that are going on in the AI space, hardware, and also software as well. I think there's some stuff going on in Snowflake and Palantir earnings. Just gonna add that here. And then on the hardware side, actually, AMD acquired ZT Systems for about $4.9 billion this week. And I want to say, so ZT Systems is a custom server designer and manufacturer, and their main really customers are I think hyperscalers, Amazon, Meta, Microsoft, Google. So I think they're actually in the business of designing these servers and then selling those to these hyperscalers to then put into their data centers across the US. Okay. Yeah, so I think the reason really why AMD wanted to buy ZT to expand its data center capabilities to compete with NVIDIA and Intel. I think Intel, AMD is already destroying them from a market share perspective. If you look at the most recent quarter, I think Intel revenue month or quarter over quarter is down like 30% year over year, maybe even more. So I think nowadays AMD is winning both on kind of the CPU front and then also in the data center logic chip front. So when I say CPU, I guess that's really referring to kind of the consumer side of things. When you're thinking about buying a HP or Lenovo laptop, a lot of the OEMs these days are working with AMD to ship out most of their products using, I think, the Ryzen series chips. That's the sort of consumer-based chips. And then I don't know the exact, I guess ZT Systems would be one of the OEMs in the enterprise side. Yeah. Expand its data center capabilities to compete with NVIDIA. Okay. Yeah. I think this is going to be pretty big, worth monitoring in the future. Let's see, what else is there? So let's see if there's any semiconductor news here. Oh, so that was last week, right? Texas Instruments, they got some CHIPS funding, and I think to build out a 300 millimeter semiconductor wafer fabrication plant in Texas and Utah. Okay, but Texas Instruments, I think they're in the business of analog chips, not the digital chips that are most commonly used today. And I think analog chips are mostly used for sensors, since they can kind of take these discrete signals as opposed to a 0 or 1 binary signal. if I got anything on my email. Okay. Okay, so going back to Texas Instruments, it seems like these are some of the analog chip layers here. And you can see that the quarterly revenue from 2021 has declined across the board for all of these chip designers and manufacturers, while simultaneously plant property, equipment, and capex, mostly plant property and equipment, have increased a lot. So that's an interesting dilemma, right? I'll copy this image. Wait. Next. Okay, CPUs, GPUs, CPUs, yeah. Okay, so I think that's kind of like the takeaway here, right? You have these mixed model semiconductor companies that are involved in analog power and specialized semiconductor designing and manufacturing. But they're facing a tough period right now, sort of this down cycle in the semiconductor industry as a whole, where across the board, revenues are down about year over year. But at the same time, you have this ramp up in plant property and equipment spend. So you have this really big cash flow compression from this simultaneous mix of lower sales and then also higher PP&E spend, which kind of raises a question on whether or not this business model can survive. Yeah, that one's interesting. Okay. Let's see, on the software space, I think Snowflake. Earnings. Alright, yeah, let's take a look at their earnings presentation then. Okay, so I think for some background, I think Snowflake is a cloud-based data platform. So they don't actually have any really on-prem solutions. Okay. Workloads. I guess maybe this kind of is stored as a data warehouse database. Okay. Platform architecture. So I guess these are all the consultants that are actually using. Okay. Somewhat helpful, not really. Also, it's headquartered in Montana, which is crazy. Okay. Data storage, okay. I'm actually very curious to see what the demo is. I'm gonna pop in some headphones and listen to this real quick. So I wanted to move. I was kind of being loud over there, so find a more quiet place. Alright, got my headphones popped in. Gonna try and look for this demo here. How's this sound? Okay. What is Snowflake 8-minute demo?
Thank you for joining us today for this demo of Snowflake's UI. My name is Peter Mebin, and I'm a sales engineer here at Snowflake. Snowflake's platform enables a number of different workloads for users on top of any of the 3 major clouds. We believe that you should have one platform where you can store all of your data, regardless of its structure, where you can provide managed, secure access to it, and leverage the unlimited scale of the cloud. Finally, we believe you should be able to do all of this without having to manage infrastructure, so that you are only focused on getting value out of your data. On top of the technological benefits that Snowflake provides, the idea of the data cloud is really the idea that value in Snowflake comes from the content that you get access to as a Snowflake customer. Because data sharing is so easy in Snowflake, you can not only monetize your data through the data marketplace, but you can bring in external data to enrich your internal data sets without having to manage FTPs or go to cloud buckets. You can get all of this data live from the providers with minimal management. In this demo today, I'm going to give you a brief tour of the UI. I'll show you how to load data into Snowflake. We'll talk about scaling compute warehouses. We'll also briefly touch on semi-structured data and how you can query that in Snowflake. We'll talk about our data marketplace and overall data sharing features. And we'll briefly touch on creating visualizations and dashboards in the Snowflake UI. The data we'll be dealing with today is City Bike data. City Bike is a bike sharing service. We're going to be focused on data in New York City. And the data we'll be dealing with is about trips and stations. We're also going to bring in some of our own weather data to augment these data sets. In the Snowflake UI, you can see that I'm signed in with a DBA City Bike role. I'll go through these tabs here. The first is the Worksheets tab, and we'll get into what a worksheet is a little bit in a second. We've got dashboards, which we'll also talk about later. Under the Data tab, you can see your databases, and you can drill into these further to see schemas, tables, views, etc. This is also where you'll get access to the data marketplace. The Compute tab is where you're going to manage your warehouses. So at Snowflake, we separate storage and compute. Compute is what's actually doing the work on your data, whether it's loading it or transforming it or querying it. When you create a warehouse, you'll give it a name, and you're going to choose the size. An extra small is a 1-node cluster, and you'll see that with each step up, the number of resources doubles. Snowflake charges per second, so if you have an extra small running for 1 hour, you will see that it consumes 1 credit. We also have multi-cluster warehouse. In this situation, Snowflake will start off with 1 extra large warehouse. As users sign into the system and start using this warehouse, we don't want there to be resource contention and a degradation of performance for those users. With multi-cluster warehouse, Snowflake will automatically spin up an identical extra large cluster and balance the queries between the two. It can do this up until 10 clusters so that end users see no degradation of performance regardless of how many users are accessing that warehouse at the same time. And just as Snowflake automatically scales out, it will scale back in when those resources are no longer needed so that you aren't paying for them unless that they are being used. Let's get into the demo. We're going to start off by loading some trips data. So I've set up a stage where I've staged 232 CSV files. We'll see that this data as a whole represents about 2.2 gigabytes of compressed storage. I'm going to create a table for this to land in, and I'm going to go ahead and start copying data into this table. You'll notice that I'm only copying data from 2020, and if I look at my warehouse size, my load warehouse is a small. So we'll see that we loaded 40 files in about 12 seconds. This equates to about 20 million rows. But if you remember, I had 232 or 242 files in that stage. And I don't want to wait for all of those to load. So you can see within seconds, I scaled this up to a large warehouse. So I went from a small to a large, which is a 4x increase in compute resources. Now I can copy in the rest of the data, and you should see that it runs in about the same time, maybe a little bit longer. And we're gonna load in the remaining 192 files that were in that stage. There we go. We can see we loaded 192 files in 13 seconds. Now that I'm done with that, I can scale the warehouse back down to a small because I don't need the large resource. We can see that I now have about 116 million rows in this table. And if we take a look at the data, it's just data about the trips. So how long they took and where and when they started and stopped. I've also got stations data that I've already loaded in. And I've got weather data. And what's interesting about this table is it only has 2 columns. One is V, and this holds the entire JSON file for this weather record. But what's really interesting in Snowflake is I can use basic SQL to query this. So using a simple dot notation, or I'm saying go to the V column, go find the city key, find the name key, and then cast that value as a string, I can start pulling data out of this JSON file without actually changing the underlying file at all. Now I'm going to go ahead and I'm going to change my warehouse to an extra large. And I'm going to build a view that combines the trips data and the stations data together. We can see that now, instead of just having the station ID, we have information about where the stations are. And now I can add in my weather data. And again, this data is still stored in its native JSON format, but I can pull out the values I need into this view with basic SQL syntax. So if I scroll over, we see we still have our trips and stations data, but now we're also pulling in weather data, even though we haven't changed anything about the data as it's stored in Snowflake. What we could also do is we could go to the data marketplace to find weather data. So I could go to weather, I could find free data sets, and I can bring these into my environment very easily. I can click get data. I'm going to simplify this and just call it weather, and I'm going to make it public for everyone to see. Accept the terms and conditions, and that's it. It's all done. So if I go back to my worksheet and I refresh the page, you'll see that I now have access to this weather database. And all of these views that I have access to, I can query as if it's my own internal data, and I can combine it with data. And again, once I set up this share for the first time, I don't have to manage this to keep it up to date. When Weather Source updates the data on their side, I will automatically see that updated data in my environment. In Snowflake's new UI, we also have some light visualization tools. You can see I ran a query here and I got the results back. On the right, we have some light visualizations where I can do some data discovery and drill down. And I can also build out some visualizations. So here, I'm just mapping the number of trips per day over time. And I can change the bucketing, so I can do it on a daily basis or a weekly basis or a monthly basis. And then once I've created this visualization, I can add it to a dashboard where I can now see all these visualizations that are pertinent to the city bike data on one screen. Thank you for joining us today for this demo of the Snowflake UI. If you have any questions, please check out our Snowflake documentation on our website.
Okay,
if you want to learn more.
It's like Snowflake, it's like a tool for data analysts to just read in data, query it, and also do a lot of visualizations in-house. So it seems like it's a competitor to SQL Server. I wonder if there's anything that Amazon makes for this.
Wow, I just built the most amazing workflow on Monday.com.
You build your own workflow? Why? There are a bunch of
Snowflake charges per second. So if you have an columns.
Okay.
Shashank recently pointed out that he wasn't really clear on the difference between Snowflake versus Databricks. In both cases, I really do think it's impossible to talk about either of these solutions in a comparison without talking about the founders. The reason is, in both cases, I believe that the founders and their kind of mentality on how they approach data changed the product, or maybe not changed, but was the foundation for the product. In my previous video, I kind of referenced this a little bit, but let's kind of give a little more color to this concept. Let's start with Snowflake. Snowflake was developed by 3 data warehousing experts that 2 of which worked at Oracle, and 1 was the co-founder of VectorWise. Their names were Benoit, Terry, and Marcin. With having backgrounds in what I would consider traditional data warehousing and database management, Snowflake makes a lot of sense in terms of what they develop. Now with Snowsight, I think it's transforming and getting to that next step of offering that ability to create notebooks and workbooks. But originally, it felt like your traditional data warehouse or database solution, just in the cloud. Now, compare that to Databricks, which essentially started in academia at AMP Labs in Berkeley University by several professors and TAs, their names being Ali, Andy, Arsalan, Yon, Mate, Patrick, and Reynold. And I'm going to put their last names up as well. I'm going to butcher too many names. And you can kind of get the sense as you scroll through Databricks product that it was really focused around the notebook. Yes, it was focused around Spark, but as you kind of go through it, everything is connected to the notebook. You create notebooks that then create jobs, that then create tables, and everything was really developed personally more for data scientists. It's, again, not meant to hinder anything or take a shot at it as a data engineer. It's just that's what it feels like. It's been further developed since then, and I think it does a lot more now, but you can kind of feel like that's where it started. Like that was the center, that was its core. In the same way that Snowflake, when you look at it, its core wasn't necessarily these workbooks that it's now kind of going into, it was more around data warehousing. And that's why both of these solutions are now pushing into becoming your data platform, your data OS, whatever you want to call it. That's where they want to go because they know that is that next level. It's not just about their product and how you use it, but it's how you think about it. They want it to become the thing that you go to build everything else off of. That's why Snowflake has built Snowpark. That's why Databricks wants you to think of them as a data lakehouse. And we're going to talk about more of these differences, but it's important, I think, to understand that they're philosophically kind of different, at least from the start. They have a different approach to how they view data, and that's what I think is kind of pushing the rest of a lot of their differences. Now, with that, let's talk about infrastructure. The actual infrastructure and setup of these 2 solutions is very different. Back in 2016, I went to my first accidental Snowflake discussion where they were basically just doing a sales pitch on Snowflake. But honestly, early on, it felt more like a discussion of solution design or infrastructure, which was really fascinating until they got to the point that it was clearly a sales pitch. But they were talking about how they had these virtual data warehouses that would then basically sit on top of whatever kind of cloud storage you were using. I think at the time it was S3. I don't know if they had gone all the way to all of the solutions at this point. And then on top of S3, they would sit and would create micro partitions. Basically, these micro partitions would be how they would store your data, and then they could index it, and then they'd use these virtual warehouses that they could scale up and down as needed so that you could have this auto scalability and use however much basically compute you needed. And that was the big thing. That was the big thing back then. And companies had been doing kind of some separation of storage and compute for a while. I think BigQuery was definitely first, and there might have even been a company prior to this, but Snowflake was definitely the one that made it, I think, cool. Like they were the ones that made it the almost core of some of their product, right? Like it's a lot of what drove their product. They had their micro partitions, which was a lot of how they had made sure they indexed and stored data in such a way that it was fast to pull up. But it was also that separation of storage and compute, which you can kind of see in these diagrams that I'm putting up, that allowed you to scale.
Okay, so like one question I do have this is, okay, how come cloud providers aren't doing this themselves? Essentially what Snowflake seems like they're doing is you're just storing data and scaling your compute whenever you need it. What is compute? Pulling in data from your warehouse, querying that data, maybe doing some calculations on the data, like finding averages or something like that. It seems like something that would fit very well within an AWS or an Azure platform. And I'm surprised that they actually haven't added anything like this in their platform offerings. So I'm very curious about exactly what's that going on.
Like if you needed who knows how much compute, basically infinite compute, you could do it. You could do it tomorrow. You could just click a button, drop down to extra large, and spend a ton of money and run whatever amount of data you need. Now, when we go over to Databricks, it's a slightly different approach. In Databricks, what you do is you create clusters that basically are a representation of Spark compute. You can have them at different sizings. These will allow you to somewhat change sizes as you're running them, but you do need to create each one. It's somewhat similar to needing to create an actual warehouse in Snowflake, but I feel like it just takes a little bit of an extra step because there's a little more in configuration. You'll see that when you're building out a Spark cluster, but you'll see that their processing engine is Spark. Whereas Snowflake had built a SQL-focused engine, Databricks used Spark. And the great thing about Spark, for anyone who's used it is not language agnostic, but it is more of a polyglot kind of processing engine, meaning if you have Scala, meaning if you have Python, meaning if you have Spark SQL, all of that can be run through Spark. That's great. It means you aren't limited to SQL. It means you can run a whole host of other complex operations that aren't tied to SQL. So instead of doing what Snowflake did, which was use S3 to store your data, you're going to use Delta Lake. Now, similar to Snowflake, this infrastructure also separates storage and compute. So you can use Spark to process your data. And in terms of storing it, you can use Delta Lake, which Delta Lake is Databricks' kind of storage solution. It provides you the ability to have ACID transactions, which is great. So you can have the reliability of your standard database with a Delta Lake. Which Delta Lake is Databricks' kind of storage solution. It provides you the ability to have ACID transactions, which is great. So you can have the reliability of your standard database with a more data lake feel. And we're going to get into that in a second, but that's kind of why Databricks sells itself as a data lakehouse and not just a data warehouse, because it does give you that ability to store data in varying formats. You can easily stream data into it. It's much more developed for that. You can do it with Snowflake, and we'll get to that in a second. But definitely that's more of a native feature of Databricks and kind of Delta Lake in itself. And it also lets you interact with data in multiple formats, such as Parquet and Avro, as well as storing data that's maybe semi-structured or doesn't have much of a schema defined early on that you can then define later on as you're building tables off of your data, allowing you to unify kind of the data lake portion as well as your data warehouse portion. So you can kind of store some data, maybe more of an open format, and then push it into tables eventually. If you recall from my prior video where I showed you that tables is something you can build. So you can start defining your tables over time rather than having to rush to them immediately. So if it wasn't clear, Snowflake uses their virtual data warehouses and the proprietary SQL engine to process your data that it stores, often in some form of S3 or Google Cloud Storage or Azure Blob Storage, in what they call micro-partitions that they've indexed. So that's kind of how they've got it all set up. And Databricks uses Spark as the processing engine that sits on top. Process your data that it stores, often in some form of S3 proprietary immediately. So if it wasn't clear, Snowflake uses their virtual data warehouses and the proprietary SQL engine to process your data that it stores, often in some form of S3 or Google Cloud Storage or Azure Blob Storage, in what they call micro-partitions that they've indexed. So that's kind of how they've got it all set up. And Databricks uses Spark as the processing engine that sits on top of Delta Lake. From there, we need to talk about scaling. Because let's be clear, if you're building in the cloud, one of the benefits that you would be amiss to not take advantage of is scaling as you need to. Now with Databricks, you can scale pretty easily. One, you can set it up to auto scale if you don't mind possibly accidentally running something at a higher cost. You can turn this off and on, but that is an option. You can auto scale so that it can process more data as needed. But in addition, you do have to have some idea in terms of what all of these sizes mean. So if you scroll through, it is slightly more complicated. And it's not huge. But when we compare that to Snowflake, they have done something that just simplifies it all together. They literally describe it as t-shirt sizes. And maybe that's overly simplistic for some people, but that's how they say, it's extra small, small, extra large. It's very easy to understand how to scale your Snowflake compute. And you can set it up to scale out to a multi-cluster warehouse to accommodate, larger number of maybe users or queries that are being run all at one time. So not only can you essentially take advantage of using more compute, you can start setting up multiple clusters of your warehouse to kind of run more independently, so they're not bumping into each other, which is a common problem if you've ever run anything on an on-prem data warehouse, is that eventually you do hit a point where you can't just like copy another server. You can't just, be like copy paste another server. But this essentially lets you do that. It can essentially let you isolate compute and storage, and so that they can kind of almost scale infinitely. There is a point of diminishing return for either Databricks or Snowflake. I'll kind of put up a chart here. At a certain point, you end up going from basically almost like doubling or quadrupling your speed to almost just having a minuscule amount of difference when queries get large enough. But that query can essentially run in isolation without blocking other people who might also be running other analytical queries. So that's also another benefit. You might have a really long running query that will cost you a ton of money, but it won't necessarily ruin other people's day. Now, I would love to talk about cost, but Databricks and Snowflake have done this to death. I mean, if you missed it earlier, I think it was this year or last year. It was last year, the end of last year. Snowflake and Databricks decided to have it out with each other as they both passively, aggressively, and maybe aggressively wrote articles calling each other out. They both essentially ran the TPC benchmarking data set, and both were basically pointing fingers and calling out, BS. And there was a lot of fun that if you missed it, I'm going to put up some of the articles and just the titles. One, Snowflake flat out said that Databricks was lacking integrity, and Databricks fired back saying that Snowflake essentially lacked integrity. And it was an interesting moment in time. But I do agree with one part that I read that Snowflake kind of put out, which was, if you read their article that they put out, that 20 years ago, the game of leapfrogging benchmark results every few months was a priority for the database industry. And both of us were on the front line fighting the benchmark war. Skipping down a bit, they also added in, most in the industry started adding in configuration knobs, special settings, and very specific optimizations that would improve a benchmark by a fraction of a percent. And this is kind of an extra point that I wanted to add in, which is, especially with cost, when you add in all these like abilities to optimize and, just configure things down to an even finer point, it often adds costs. In fact, this was something that's been known, I think, about Oracle, where Oracle was often really expensive to maintain, not just because of their licensing, but because it allowed you to fine-tune everything so well that you had to pay for very expensive consultants to manage it. And so there's a total cost of ownership and total cost of basically managing and operating the systems that it's almost impossible to say personally which one's going to be cheaper for you. Because at the end of the day, maybe you pay more for Snowflake, but maybe you have one less person that you had to hire. Maybe. I'm not saying that that's the case, but it could be the other way around too. So I'm not going to sit here and say that Databricks is cheaper or Snowflake is cheaper, because talent is a real cost and you need to include that into your calculation. And it's kind of hard to know how much talent you need. So we're not going to go too deep into costs, but do read those articles. It's pretty funny. I'll link them below. Now let's talk about data types. When it comes to Snowflake, it does...
Okay, so I want to make some notes. There's a lot of interesting things being talked about in this. Not all of it is useful for the weekly update, but I think it's interesting in the broader context of the idea of data software. So Snowflake versus Databricks. Seattle data guy. Yeah, I think he deserves a sub. Yeah. Okay, so Snowflakes versus Databricks. Trying. Okay, so I think that's essentially kind of the strategy behind both of these companies. they want to be the platform of choice or the data operating system of choice where you can store data, query data, and analyze it, right?
Does provide you the ability to work with several semi-structured data types, along with your kind of classic
Okay, I think beginning, so Snowflake inception, right? Snowflake was focused on scale, separate storage, and data warehouse, compute, did this through virtual data warehouses that utilize the cloud under the hood. So I guess, yeah, with Snowflake you are sort of limited to the SQL engine, but I guess with Databricks and the Spark engine that they're using, it is language agnostic, okay? No, I am actually kind of curious. Databricks careers. Students and credits. No. So very much. Okay. Data analytics. Jeez, work. Okay. Yeah, Delta Lake, I think, is what. Delta Lake. Database. Okay. Was on Apache's support. It's data engine. Okay. This allows the users to use like our scale. Okay. So that was the big thing at inception, right? Business development. Let's see. I think this is pretty much all we need to know at a high level. I feel like if we talk about some of the other stuff, it might get too deep into the weeds right now, and I don't really want to.
Ints and floats and things of that nature. So you can use the variant data type object or array. In addition, on top of that, they actually allow you the ability.
Okay, I think I'll stop this for now. I think I have a good understanding somewhat of a high-level business model between the two. Okay, and now let's go to Snowflake. Let's see if we can go back to the investor presentations again. Oh, 10K, damn. All right. Okay, I guess nowadays, alright, so Snowflake is compatible with kind of the core languages here. Net revenue retention rate, okay, so it's a decent amount. Product gross margins. Okay, so I guess their fiscal year end is 1 year early. Remaining performance obligations. Okay. Oh, yeah, this is tough. See, the retention rate has fallen consistently. Okay. That's it. I wonder when Databricks. Oh shoot, yeah, Databricks isn't public yet. Okay. It's a bit fun. So maybe there's some more churn going on. If they're booking. So what is net revenue retention, right? I think it's annual recurring revenue minus churn plus cross sells, upsells, and new logo. Divide that by the previous. Okay, let's see how they define it, right? Okay, so it seems like they take a 2-year trailing period. They take the revenues in the second cohort, divide that by the revenues in the first cohort, and that's how they get their net revenue retention. Okay. Very high level, yeah. When was this? August 21, okay. Yeah, I'm kind of curious on what Palantir actually does. I do need to go use the bathroom though. So I think what I might do is, stream for about an hour now. I think I might end the stream here. And let me see if I can find anything on Micron News. Tech News. Oh, shoot, tan. It's a terrible Amazon, Apple. Okay, this could be an interesting one. Yeah, this doesn't seem to be too much going on here. Yeah, I guess after the fact, if earnings, there really isn't too much. I think sector news. Yeah, maybe not too much going on. Okay, so I think I'll probably end this one here, and then I'll come back in maybe like 15-20 minutes. Yeah, I'll come back in like 15-20 minutes and try to finish up the last parts, maybe delve into Apple a little bit, and also talk about this Palantir earnings. I think this was this week. Oh, never mind. Okay. Okay, earnings release calendar. Tech. Billy, Macrobank, Peloton. Interesting. Workday could be interesting, actually. Synopsis. Okay, so maybe I'll talk about that. I don't really know exactly what synopsis does, so it'll be interesting to see. Alright, I want to add so Workday and I think Workday is a provider of human resource software, and then okay, yeah, and this will probably end here, and thanks for tuning in to this week's tech coverage, and I'll come back soon, try to finish some of the other stuff. Alright, see you later. Peace.